All right, we turned our journal page from what we just did, and I want you to get in your math workbook and tear out page 105. Again, it's page 105. I want you to tear out, and you can put a big X through page 105 because look, we already did these ones in our journal, and then I don't want to spend time on Puzzle Penguin, so put a big X on this side, but make sure to put your name and number on it. Then turn it over, and we're going to be cutting out certain numbers. So I'm going to write the numbers on the top of my green part right here, and I want you to make sure that you also cut out these numbers. The ones we're going to be gluing in our journal are numbers 4, but not with the line, okay? We're just cutting out just the story problem. Number 4, 5, 6, and 8. 4, 5, 6, and 8. So you're going to get a pair of scissors, and you're going to get this all cut out. So while I'm cutting mine, you should also be cutting yours. So 4, 5, 6, and 8. Remember, I don't need the blue lines. I just want the story problems. So 4, 5, 6, and 8. Sorry, I don't even need this stuff. I don't want the title or any of this. Just 4, 5, 6, and 8. Now I have 4, 5, 6, 7, and 8 on here. But remember, I'm going to be cutting out those. Maybe leave the orange numbers. It's not hard to do that. But just cut out the story problem. There's number 4. Don't you just love cutting stuff out for your journal? There's number 5, 6, and 8. There's number 6. And the last one I need is number 8. You can throw all the rest of the scraps away. And you need a glue stick out in order to glue these in your journal. So let's evenly space these out. If I've got 4 story problems, let's just keep them in this order. We'll do number 4 right here up at the top. And then we need a number 5, and then a number 6 space, and then a number 8 space. Number 8 is kind of going to be more towards the bottom. We won't need a lot of space to work this one out, so you can see kind of where the bottom of my journal is. And that's where you're going to put number 8. So just kind of space them out evenly, get them glued on there, and then we'll begin. You need to still leave out your colors that we're using because depending on what operation it is, we're going to use that color. So if it is add, like if you see that the story problem is going to be addition, then we are going to use that red-violet color. If the story problem is going to be subtraction, then we will use the subtraction color, which is the aqua blue. If it's multiply, we'll use yellow, and if we're comparing, we'll use orange. So get yours glued on there. I'm just going to quickly use tape so that we can move along. 4, 5, 6, and 8. If you are not where I'm at, then you should quickly push pause and get caught up, okay? All right, I'm ready to move on to number 4. Number 4. Let's get our colors out and ready, and let's search for the key words. Number 4. Yesterday, Mr. Swenson made 2 3/4 quarts of strawberry jam. Oh, I love good strawberry jam. And 1 1/8 quarts of raspberry jam. How much more strawberry jam did he make than raspberry? Do, 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 do. I see a phrase that means subtraction. Do you see it? I picked up the right subtraction color. Here it is. How much more? That means we are going to be doing subtraction. So let's do that off the side and let's show our work underneath. So with subtraction, it does matter which one goes on top. You have to put the one that is more on top. And in this case, I clearly know which one is more because it has a 2 in the ones place. This one only has a 1. So I just stack them up. 2 3/4 minus 1 1/8. Why is my equals bar long? It's because I'm going to be changing these to have the same denominator. So think about 4 and 8. Which one is higher on the number line? 8. So you list multiples of 8 and tell me when to stop. 8. Stop. 4 can change in to an 8. Those are the best situations because then you're only dealing with one fraction. How did I get from 4 to 8? I times by 2. And 3 times 2 is 6. So that just changed to 6/8. Wiki wiki. And then I have 1/8 already there. So now I can do the fraction part. 6/8 minus 1/8 is 5/8. And the whole numbers, 2 minus 1 is 1. So my final answer for that subtraction problem is 1 5/8. However, it is a story problem. So we will write a sentence with the correct labeling or measuring that we need to write. So, how much more strawberry jam did he make than raspberry? He made 1 5/8. What's the measurement? Cups? No, quarts. He made 1 5/8 quarts more of, which one did he make more of? The strawberry jam. He made 1 5/8 quarts more of strawberry jam. Number 5, get these colors out. Be searching. What are some clue words? Are we going to be doing subtraction? Are we going to be doing addition, comparing, or multiplying? Today, Mr. Swenson is making 2/5 quart of grape jelly. He will give half of this amount to his neighbor. Not half a quart, half of this whole amount. Half of this amount. How much jelly will the neighbor get? So he doesn't give half a quart. If he gave half a quart, then I would be doing subtraction. But guess what? It does not say half a quart. It says half of. Why am I choosing yellow? Because if I ever say half of something or 2/3 of something, then I'm doing multiplication. I'm taking a piece of that. So this is multiplication. I just want to make sure you remember that multiplication can be represented with an X or just a plain dot. So I did both of those on the side. Okay, so I multiply 1/2 of or times 2/5. And like any multiplication problem, we start with extending the bar like this with it when it comes to fractions. And I look for relationships. You never have to check the ones. So I come over here, this 2. Does it have a relationship with 5? No. What about with 2? Yeah. If there's a 2 on top and a 2 on bottom somewhere, they just cross each other out. They cross each other out. You can technically change them to 1s if you want, but I just cross them out because then I know what I'm left with. So what I'm left with is 1 times nothing is 1, and nothing times 5 is 5. So the answer is 1/5. He gave 1/5 quart of grape jelly to his neighbor. So he gave half of what he had. Think of that. Look how easy that is. If he only had 2/5, what's half of that? It's 1/5. And now I just proved it. That's pretty cool. So let's write it in a sentence. So how much jelly will the neighbor get? The neighbor will get 1/5 quart of grape jelly. Ooh, I love grape jelly too. There's very few types of jellies that I don't enjoy. Yeah, I don't really like peach or apricot or any of that kind of stuff. I like any of the berries in grape. That's delicious. All right, number 6. Sorry for the jelly story. Mr. Swenson is also making 2 1/6 quarts of cherry jelly. Wow, he is a really good jam maker. Do you know the difference between jelly and jam? I do. Maybe you should look it up if you don't know. Anyway, Mr. Swenson is also making 2 1/6 quarts of cherry jelly. Oh, make sure you have all the colors ready to figure out what it is. Is it going to be multiply? Is it going to be add, subtract, or compare? Mr. Swenson is also making 2 1/6 quarts of cherry jelly and 3 1/12 quarts of orange jelly. He will mix the two kinds together. How much of this mixed jelly will he have? So he has this amount and he has this amount. He's going to mix them together. So I put them together. The key word there is mix. And so we will be doing addition. If you knew that, congratulations. So mixing them means addition. I am going to be doing addition. Okay, here I go. So it doesn't matter with addition which one goes on top. So I'm just going to do 2 and a 6th added to 3 and 1/12. So I start with 6th and 12ths. You have to make them have the same denominator. Luckily, that one will just change to 12ths. How did I get from 6 to 12? Times by 2. And 1 times 2 is 2. Wiki wiki. So 1/6 just became what? 2/12. All right. I'm still doing fractions. 2/12 plus 1/12. Good. 3/12. Those have factors in common. But I have to deal with that later. I do whole numbers. 2 plus 3 is 5. I wish I would have written that a lot bigger, so let me try that again. 2 plus 3 is 5. So right now I have 5 and 3/12, but 3/12, my friends, you need to simplify that. So don't forget that you have a 5, and let's fix the 3/12. So when I take 3/12, I can divide both of those by a common factor, and 3 only has the factors of 3 and 1. So you just divide these both by 3. By 3 over 3. So the top number will be 1, the bottom number will be 4. Now I want you to go back to what you had. You had 5 and this fraction. Well, we simplified the fraction, but you can't forget the 5. So I'm just going to kind of go, I have this, and I have this. This would have been a Medal of Honor if I would have had space under here. So just put those together. So I have 5 and 1/4 is my final answer. But because it is a story problem, I will put it in a sentence. How much of this mixed jelly will he have? He will have 5 1/4. What's the measuring? Quarts of this mixed jelly. Okay, we're on to our last problem. So we've had 1 subtraction, 1 multiplication, 1 addition. I'm thinking this one might be comparison. But let's pull out the orange and see if it's correct. Number 8. Suppose Mr. Swenson has jars that hold 5/6 a quart, jars that hold 3/4 a quart, and jars that hold 2/3 a quart. Which size holds the most? Yep. Anytime it says holds the most or holds the least, we're going to be doing what? Comparing. Look, you can make the scary comparison face. We're going to be comparing. If you don't know what I mean by that face, let's pretend that it's eyes and a mouth. Okay. So I'm going to have to compare 2 at a time and then throw the other one in. So let's just start comparing the 5/6 and the 3/4. I'm going to come here. 5/6 compared to 3/4. Find out which one of these is bigger first. I know already, because if you're running a race and you're so close to the finish line, is 1/6 closer to the finish line or is 1/4 closer to the finish line? 1/6 is, because it's smaller away from the hole. So the 5/6 is actually greater. So it looks like that. So I know right now that 5/6 is bigger than 3/4. Okay. What about 2/3 though? How do I know about 2/3? Should I compare 5/6 to 2/3? Yeah, let's see if 5/6 is the biggest one out there. So now we need to compare the big one, 5/6, to this other number, 2/3. Now we're going to do 5/6 compared to 2/3. Same thing. This one is closer to the finish line than that one. If you didn't know, you could cross multiply. 3 times 5 is 15. 6 times 2 is 12. So 5/6 is still bigger. So guess what? Ta-da! I have found the jar that holds the most. because 5, 6 was bigger than this one and bigger than that one. So which jar holds the most? What should we do? Should we circle? Let's just write 5/6 quart holds the most. That's this part of the question. Now I need to know which size holds the least. So we're not looking for, we're going to now compare this 3/4 and 2/3, and we're not looking for the biggest one, we're looking for the smallest one. So let's compare those two. Now we have to do 3/4 compared to 2/3. You can do the whole finish line thought process again if you want, or you can cross multiply. 3 times 3 is 9, 4 times 2 is 8, so 3/4 was bigger. But we want to know which one holds the least. So out of these two, which was the smaller fraction? 2/3. So 5/6 quart holds the most. 2/3 quart holds the least. So we answered the second part of the question. But now it says, how do you know? So I think I would just I would write it like this. So I'd put this in like a cloud. And because I'm out of space, I'm just going to write it over here. I'm going to write, I know this because I compared the fractions. That way I've answered all of the questions. I know this because I've compared all of the fractions. Okay, so we just did our first page of a journal, which was practicing all of the different operations. Then we put them into real life and saw if we could figure that out. Now it's your responsibility to figure out what you need to be doing. If you need to be doing Think Central, then you should get on to Think Central. Otherwise, you should be able to get out your homework and remembering. The homework page looks like this. I wanted to just show you this so that you can be clear. This is just what we did in our journal, this chart, but they used a dot instead of an X. That still means multiply. One thing I wanted to show you here is you don't have to write it as the fixed fraction or the equivalent. Here's what I mean by that. They took 3/4 and they changed it into 6/8. You don't have to do that. Ms. Fisher's okay with you just writing, they give you the first one, and then you just reversing it and writing it the other way. Okay, so go ahead and do that if you want. Let's do this number 2 one together so you know what I mean. So remember, Ms. Fisher said you can just compare, and then you can write or, and then compare it the other way. That's what I mean. So figure this out. What's bigger, 1/2 or 3/5? Well, 1/2 of 5 would be 2.5, and I have 3, so it's more than 1/2. So it looks like that. So 1/2 is less than. So that means that 3/5 is bigger than 1/2. So that's what I mean by that, is you don't have to change these denominators. You can just write it like that. When you add and subtract, you will have to do what we did in our journal. You'll have to stack up. I would start with the adding. You'll have to stack it up to the side, do the work, and then use your journal to know how to solve these problems. We just did this together. So do not guess. Do not only show me answers. You have to show the work that you used in order to get to some of those answers. Okay? So don't be lazy on this. But numbers 1 and 2 are just practicing. And then 3 through 7 are real world operations. So you can do that. We just practice some of those as well. Look for keywords. You don't have to use the right colors or anything. You can just use a pencil. And then on the remembering side, you're going to do all of the remembering. On numbers 7, 8, 9, and 10, on this one, I would really try to solve these by following the directions, because it says find each product by first rewriting each mixed number as a fraction. So you have to do this whole multiply then add. Do you remember how fun that was so long ago? So 9 times 4 is 36, plus 4 is 40 over 9, because the denominator is stubborn and it stays. And then I'm multiplying it by 3 times 2 is 6, plus 2 is 8 over 3. How did I know it was over 3? Because the denominator is stubborn and it stays. So then you're looking for relationships here. You would extend the bar. You can use a crayon if you want, or just your pencil. And 40 doesn't have a relationship with 9. I don't think 40 has a relationship with 3, because 3 times 12 is 36. 3 times 13 is 39. 3 times 14 would be 42, so it's too much. So it doesn't have a relationship with that. What about 8? 8 and 3? No. 8 and 9? Nope. So you have to do 40 times 8 over 9 times 3, which is 27. 40 times 8, that's easier than you might be thinking. 8 times 4 is 32, and it just has a 0. But you're going to have to keep fixing this. So you're going to have to say, well, how many times will 27 go into 320? No. Do I have to solve it, or do I get to leave it as a fraction? Oh, it does say find each product. So you do have to solve this. So then you just go, okay, well, I do 320. Remember that fraction bar means divided by 27. It's really not that hard. 27 goes into 32 once. I subtract those. You should know long division from 4th grade. 27 goes into 50. Oh, if it was 25, it would go in there twice. But it's not 25, so it only goes in there once again. And then when I subtract, I get 23. So my answer is 11 and 23 27ths. 11 and 23 27ths. That was crazy. Good thing I helped you with that. I'm thinking the rest of these are going to be a little tough too. Look at number 8. Good thing I'm being nice and helping you. Multiply, then add. 6 times 5 is 30, plus 1 is 31 over 5. Times by, how do you change 10 into a fraction? You just throw a 1 underneath it. That's pretty easy. Throw a 1 underneath it. And now extend the bar. Look for relationships. 31 won't have any relationships with these, but 10 does. 10 and 5, they can both be divided by 5. So if you divide that by 5, you get 2. You divide that by 5, you get 1. So that's awesome, because there's going to be a 1 on the bottom, which just means it's going to be a whole number. 31 times 2 is 62. Final answer. So that first one, number 7, was kind of tough. Look at the next section. You're going to have to stack the, oh, that's easy. Mental math, they both are already 7ths. 12, you're going to have to find common denominators. 13, look carefully, it's multiply. So you just extend and look for relationships. Same with 14, it's multiply. 15, this one's fun. You got to stack this up. It looks so weird when you stack up a problem like that. That's what it's doing. It has 0 fractions and 0 holes on this one. So you go, hi, I need some 7ths. I can't give you 1/7 if I don't have any. So you go over to the neighbor's house. You knock 8 times. Thanks, neighbor 8. You bring back 7/7. So now you can do it. It looks like 7 and 7/7 minus a 7th. So it'll be 7 and 6/7. Number 16, you'll have to stack up. Here's what I wanted to show you. On stretch your thinking. You don't have to do it. However, it is a stamp option. If you choose to do this, you have to also solve the problem. So if you want to write stamp option, you can. You can pause the video and make sure you get this whole phrase. But you would just have to write a word problem that requires you to multiply 2 mixed numbers. So it would be doing something like number 7. But you could pick easier numbers than that. But you would also have to solve it if you wrote the word problem, and then you'll have to solve it if you want to do that for stamps. If not, don't worry about it. All right, we'll see you tomorrow in our next lesson. Make sure that you complete everything you're supposed to. Thanks, everyone.